Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Hi. Hello, everyone, and welcome to Model Mondays. This is episode number 2 in our series, which just launched last week. And we're super excited today because today we're going to have a focus on something that I think a lot of you are finding interest in, reasoning models. But before we jump in, let me introduce my co-host, Sharmila. Hi, Sharmila.
Hi, Nitya. Hi, everyone. Everyone, happy to see you all here and welcome to Model Mondays. This is our second episode, so happy to jump in and get started. Go ahead, Nitya.
Yeah, so before we kind of dive into our first segment, just a little bit of run of show for you. We have a Discord. You can go find the links in the chat. Please join us afterwards if you have any questions. But first, in our first segment, we're going to dive into the news from the past week in a thing that we call highlights or model roundup. Sharmila, take it away.
Thank you, Nitya. Now let's dive into the Model Mondays highlights for this week. As I go through the highlights, I have a QR code for every page. Feel free to take a picture of the QR code. These codes will take you to the model card page in Azure AI Foundry, where you can learn more about the model, and if you're interested, you can start playing around with the model. Now let's get started with the highlights. So today we're first going to talk about Mistral models. We introduced Mistral Large, Nemo, and Ministral models over the course of the last few months. However, what's new is that we added fine-tuning capabilities for these models in early February. Fine-tuning will help you customize models for your domain-specific data, thereby improving response accuracy, especially if you have a use case where models trained on general-purpose data will not cut it. Fine-tuning also helps to improve latency and makes your AI applications more cost-efficient. The next Mistral model we are going to see is Codastral 25.01. This is the first coding model in the Azure AI model catalog, and Codastral is trained on a diverse data set of 80 plus programming languages, including the most popular ones such as Python, Java, C++, C, JavaScript, and Bash. It also performs well on more specific ones like Swift and Fortran. This broad language base ensures Codastral can assist developers in various coding environments and projects. Codastral has a 32,000 token context window, allowing it to handle extensive pieces of code. It also supports function calling, meaning it can execute specific functions and manipulate data as part of its code generation process. And it also performs well in several benchmarks, often competing with more expensive models like GPT-4 and Claude. And Codastral is accessible through interfaces like LeChat and APIs. This means developers can start using it quickly and easily without needing extensive setup or technical knowledge. And being open source, Codastral allows developers to contribute to its development and customize it for their needs. This fosters a collaborative environment and helps improve the model over time. The next few models we're going to talk about are the Azure OpenAI GPT models. Now, we're going to talk about the GPT-4o real-time API for speech and audio, and it's part of the GPT-4o family of models. And it supports low latency speech in, speech out conversational interactions. The GPT-4o audio real-time API is designed to handle real-time, low latency conversational interactions, making it a great fit for use cases involving live interactions between a user and a model, such as customer support agents, voice assistants, and real-time translators. Most users of the real-time API need to deliver and receive audio from an end user in real time, including applications that use WebRTC or telephony system. Finally, the next GPT-4o model that we're going to talk about is GPT 4.5, which is a step forward in scaling up pre-training and post-training. By scaling unsupervised learning, GPT 4.5 improves its ability to recognize patterns, draw connections, and generate creative insights without reasoning. And early testing have shown that interacting with GPT 4.5 feels more natural, and its broader knowledge base, improved ability to follow user input, intent, and greater EQ makes it useful for tasks like improving writing, programming, and solving practical problems. And it is also expected to hallucinate less than other models. The final model highlight of the week is Gradle Navigator. Now, Gradle Navigator is the first compound AI system which is built to create, edit, and augment tabular data. You can iteratively build your own data set from scratch using Gradle Navigator, and it also enables AI-driven synthetic data generation, helping organizations overcome the limitations of human data creation. While Gen AI relies heavily on data, human-driven dataset creation is not able to scale at the pace of GPUs or AI advancements. With Gradle's synthetic data solution, businesses can now rapidly generate high-quality data sets, ensuring that data production keeps pace with both scientific progress and computational power. Now that brings us to the end of model highlights for this week. And some of the models that we talked about today, like Mistral and Gradle, we're going to have a spotlight on it in the future upcoming weeks. So keep an eye out for it and join us for those conversations where we'll go do a deep dive on these models. Now I'll hand it over to Nitya.
All right, thanks so much. So first of all, I was watching the chat while the segment was playing, and I know all of you are like, this is about reasoning models. So I wanted to just set the stage and say that Model Mondays is a series where we'll kind of just spend 5 minutes catching you up on news from the past week. That's what you saw. And then we'll do a deep dive. And now we will be introducing our guest. This is the featured segment on our hands-on with reasoning models. So I want to take a minute to just introduce Jennifer Marsman and bring her on stage. Now, before I do that, I'm going to really kind of go a little bit gog on this, because I actually saw Jennifer at a Grace Hopper event a long time ago. She probably doesn't even remember. And I remember her talking about machine learning. And it's one of the reasons why I got inspired to come into this field, because she made it sound like it was just so exciting. So I've come full circle today. We have Jennifer Marsman. Jennifer, maybe you could give us a quick introduction to who you are and what you're doing at Microsoft before we dive into a segment.
Absolutely. Hello, my name is Jennifer Marsman. I'm a principal engineer in the office of the CTO at Microsoft. So what that means is that I assist the CTO with his forward-looking thoughts on AI and kind of how to get there. So I like to say it's a lot like being a grad student, again, honestly, where you're working for a very smart professor type, and sometimes he has great ideas, and then you do some experiments to test them out. And sometimes you have good ideas and you make sure he knows about other things happening in the industry. So it's a lot like that. I also work with some large customers to help them be successful, ones that are interesting enough that the CTO has taken notice. As well as I'm the person that writes Kevin's demos. So I'm his demo engineer as well. So I do a lot of coding of that sort of thing as well.
And I think before we kind of dive into the hands-on demo portion of it, Sharmila and I, we were also talking about this. There's a reason we pick reasoning models to be our first flagship kind of feature. There's a lot of interest in the industry today around this. Can you give us a sense for why people should be looking at it before you go into details?
Yes. So what's interesting about this is that this is a whole new breed of model. When we've seen some other model upgrades. So for instance, when we moved between GPT-4 and GPT-4 Turbo, for example, there weren't a lot of reasons not to upgrade. It was kind of a clear thing where here's the model that runs more efficiently, has higher quality, those kind of things where it's a clear just keep moving. But the way reasoning models work is fundamentally different under the covers. And so what I would argue is that there are some clear reasons for using them. And then there's some times when you don't actually want to use them, when you'd want to use maybe something a little faster, more efficient, and cheaper. So I think it's a really good lesson in understanding the class of problems that reasoning models are really good at. Things that can take advantage of the internal chain of thought that they're using, and that capability that allows them to hold on to details really, really well. And then using that, it can be. So those are what I want to show you in the demo to help you kind of wrap your mind around the kind of problem where this model really shines.
I can't wait. We should jump into the demo. And I also want to encourage folks on the chat to line up your questions because once we've kind of gone through the demo, I want to come back and really have a big conversation around it. So let's line up the demos.
Reasoning models are a new breed of machine learning model that enables deep analysis, correlation detection between, multiple long documents, for example, and more complex problem solving than we've previously seen. And the way they're able to do that is by using an internal chain of thought to ruminate on these answers a little longer. So what I want to do first is share with you the very first example that opened my mind to the new category of problems that these reasoning models can solve. I was using an early version of OpenAI's O1 preview model, and what I wanted to do is actually solve what is actually a very complex constraint satisfaction problem that my family faces every summer. I love my kids, but they have to go to all of these camps in our area over the summer, and it is so difficult to plan. We have in our area where there's a different camp every week, so it's not like you can sign them up for summer camp. Every week you have to choose individual camps. And so what I did is I threw this problem at the O1 preview model. And I asked for a weekly schedule for all of my kids. And I said that I wanted 2 weeks off as well when they won't be in camp, so our family can get together and do some vacation time with me and my husband as well. Doesn't have to be consecutive, just any 2 weeks is good. And then I gave a little information about each of my kids and specifically what grade levels they are in, because that's important for scheduling. The camps are divided by grade. And then I told a little bit about their interests. One of them loves baking and dance. Another one likes reading, writing, and soccer. And the third one likes, martial arts and video games, especially Minecraft and Roblox. So I kind of set out my requirements here and asked for a different class every week and asked for an output where there's a matrix of each week of the summer by each kid and then what are they doing that week. So although this may seem trivial, this is actually an insane constraint satisfaction problem. And then let me show you the complexity of what we were actually dealing with here. Here's one page of the summer brochure. And at the end of my prompt, I kind of pointed to the summer brochure. And this is what it actually looks like. So this is just one page here. So notice that each of these, first of all, are a single week. So if we look at this pottery class, for example, this is July 8th and July 15th, and that's all it's offered for the whole summer. And note that everything is separated by grade as well. So these are only for grade 5 and 6. So only one of my 3 kids is actually eligible to take any of these courses. And so when you think about this, there's that's such a complex problem. Compounding that, there is so much going on with this formatting, right? Notice that we have bold here. There's different colors. There's different fonts. There's kind of like a little table here. There's pictures embedded. So when I was using this O1 preview model, kind of in my early experimentation, there wasn't support for image as an input yet. So what I did in the prompt that I showed you above is I actually just copied, directly from this PDF. I just kind of dragged my cursor and then did a huge Control-C on, I think, 12 pages of this data. But once it gets copied in, notice like all of the stuff we're actually losing. Like I'm losing the bold, I'm losing like the big font of each of the titles of the camps. So a lot of, very, very noisy, ugly data I am throwing at this model, and it's able to do some pretty cool things. So let's take a quick look at that. Again, this was an early experiment just on an early version of the O1 preview model. Things have improved even more since then. And I was literally copy and pasting only text. There wasn't support for images at that point. So only text was getting pasted in there. It took about a minute to run. And then one other thing I did that was a little bit tricky is I did ask it to go until August 23rd, when all of the camps were done on August 16th, just to see, like, would it be smart and choose a family time on that last week. And this is just one non-cherry-picked example of what my output looked like. And this is actually incredibly impressive. I have gone through and verified. I've run this so many times, and I've verified, and occasionally we'll get something wrong, but it does an incredible job of not hallucinating and actually placing each child in something where this, fashion design and illustration is actually offered on this week for this grade level. Every single one of these is correct in that sense. And that was just mind-blowing to me that it was able to keep up with so much nuance in this data. And in this particular example, I think this was it did a wonderful job. The only bug I would call is right here, or in the first week, it put Fiona as off. There were actually available camps for her that week, so that was a bug. It could have placed her in something there. So that was the only thing that I would consider wrong here. Note that Tori is off here on the second week, but in that case, there actually wasn't anything offered for 12th grade on that week, so that one is actually okay. And then in this case, it did our family time at the end when there was no camps offered. Putting family time is a really smart choice. So pretty cool, right? Now, of course, the next thing I did was compare this with how the former state-of-the-art models could do. So I ran the same query against GPT-4o. This model was a lot faster, so it only took about 10 seconds to run, so less than the 60 seconds about that the O1 preview model took, which is a reasoning model. But there were so many errors in the output that it was just not at all helpful. So I started documenting them of like, all right, these classes are offered for the wrong grade, so that won't work, or these are offered on the wrong week. But essentially, I just kind of eventually gave up and stopped documenting errors because it just couldn't hold on to that level of detail. There were so many details that you have to keep track of to solve this problem adequately. And so that is really the key thing that I want you to keep in mind when you're thinking about reasoning models. A huge strength of these reasoning models is that ability to keep track of a large quantity of details and really understand the nuance. And so that's why that constraint satisfaction problem operated so well. And some of the advanced, solving puzzles and really complex problems and writing code, essentially, all of these things kind of follow a similar vein where you need to keep track of a lot of details in order to be effective. So that's really what the reasoning models are bringing to the table. Now, let me show you a few more examples. So I also wrote the first one, a code-based change test I wanted to do. So I said, using the provided documentation, summarize key changes between API versions, and then give me a blog post here. And then I pasted in literally, I think I copy and pasted again from the website, 2 different versions of one of our content safety APIs in Azure that did analytics. And I gave a version that happened right after build, and then one that happened almost a year later. And it did an amazing job finding the differences in the API. To be honest, it found all of the changes that I had found, plus it found a few more that I had missed between the 2 blog posts. So that was pretty impressive. The second thing I wanted to test here is agentic workflows. So in the very early version of O1 Preview, there wasn't support for function calling yet or using tools or actions. So what I wanted to kind of understand is, if that functionality was added to the models later, which it was, how well could the model potentially do? So I tried to coerce and understand how it might do by asking a question like, hey, you're driving a Minecraft character and you have a goal of getting a diamond sword. Here's some tools that you have available. So wander around till you find something, punch something, craft something, smelt. So I kind of defined a couple of commonly used functions that you may do in Minecraft. Apologies for those of you who are not Minecraft fans, who it may not make as much sense to you. But essentially, I asked it to build a plan to use the tools to do this. And it did an amazing job again, where it was able to do exactly, the right amount of wood I would need to get. And then I kind of worked out all of the Minecraft math where like one log converts to 4 planks and some of these other things. And it did just a phenomenal job. One little nitpick is that it didn't actually have me get any coal to smelt things. It did mention at the bottom, hey, you're going to need some extra coal or some extra wood to use as fuel in the furnace. And that wasn't explicitly in my set of steps, but it did mention it. So that was maybe, minus half point credit, but this did, again, a very, very impressive job. And then finally, productivity. So I asked it to check the University of Michigan football schedule, go blue. And I copy and pasted the football schedule from a website again. And then I actually went to my calendar in Outlook and I selected a custom set of dates. I actually did, I think, 3 months from like September to December, which is essentially the college football season. And I exported that as ICS. And what that did was that actually is a text-based format. So then I just did Control V and like pasted all of that text-based format at the end of my prompt there. And again, with so much messy, nuanced data there, my whole messy, ugly calendar in there, it was able to find, all of the football Saturdays and all of the, places where the football schedule aligned with my calendar and where I had conflicts. I knew I had a wedding as a conflict, for example, and it found it. And then there was like one case where it didn't find something. I think it was like but the football schedule had it listed as like a 3 a.m. game because the TV schedule hadn't gone on. And so it didn't quite see that, but that's kind of a case of bad input data. So all in all, very, very impressive results. And what you really see here is the fact that kind of this is a new class of problems that can be solved that's a little bit more complex than what we could do before. So let me actually, don't take my word for it. I want you to go try this yourself. So all 4 of those examples I just kind of talked you through are available here in my GitHub repo. So I can point you to this real quickly. And here, if you go to github.com/JenniferMarsman/O1 analysis, you can run all of these things yourself. They're in a Jupyter notebook, so you can feel free to run this yourself, kick the tires, try it out yourself. Here's my prompt that I use, and you can see how once you paste, that catalog in, it doesn't look nearly as good, right? Because we're losing all of that formatting, losing so much information. It's so messy, and yet it was able to create such an amazing result. So super impressive, but try it yourself and see what you think. Now, the next point I want to make is that although these reasoning models are incredibly impressive, you don't have to upgrade everything to use a reasoning model. So let me give you an example of that. I have here a math story problem. I'm going to run it, and I'm using GitHub models right here, the model catalog that's in the GitHub marketplace. What I'm going to do now is actually run this, and I'm showing side by side the GPT-4o as well as O1, which is a reasoning model. And what you can see is they actually both got the same result. So both of them could solve and got the correct, 1100 is the amount of profit in this answer. But GPT-4o is able to get it a lot faster, all right? So that is just something to keep in mind. You should definitely experiment. You should definitely try the models. But if you don't need a reasoning model, currently they are more expensive and slower to run. So at this point in time, I would really test, experiment, and use the right model for the job. And whatever is the smallest, cheapest model that can actually solve your problem is the one you're going to want to go with. However, that doesn't mean that everything is possible. Here's an example of a Wordle, and just if you're a visual person, here's what that Wordle board looks like. For a quick second, I can show you. We have something that looks something like this. And what I'm going to do is put the same thing in here where I'm going to ask it, hey, if I'm playing a game of Wordle, I've tried these words. This was the feedback of what letters were yellow versus gray versus whatever. You can see, again, same thing where O1 is going to take a little bit longer to respond, but the response is usually much, much higher quality. So in this particular example, GPT-4o is telling me that a good guess would be forge. That is actually not a good guess, given what we know. Because right here, what it's saying is it's using the E on the end. And let me just show this right here again so that you can see. We know that the E is actually in the 4th place right here, not at the end. So forge, although it uses the O and the R in different places, it's trying a G right here, but it's not using the E in the best place. So that's not necessarily the best guess here. Now, when we look at the response from the reasoning model, that is O1, you see that this one actually gives an even better result. So it suggests coder, and coder is actually a pretty good guess when you look at that. It's trying these things in a new position. It's keeping E in the correct position. And this is something that actually is a valid choice and gives you new information, and is kind of a better guess. So that's kind of the level of complexity. I hope these examples are opening your mind to the class of problems that reasoning models can solve. Now, one last thing I want to make sure you know is even beyond O1, there's support in the Azure AI Foundry model catalog for a wide number of reasoning models. You can see down here, I see a couple of reasoning models. Here's the O3 Mini is a great one. DeepSeek R1 is a reasoning model. Here's O1 and O1 Mini. So there's a wide variety of reasoning models here as well. So you can utilize whichever one works best for you and run it on Azure through the model catalog. And then you can do that same kind of experimentation right in the Azure AI Foundry chat playground as well. So I can run certain questions right here in the chat history and see how well it does here too. So hopefully that gives you a good sense of what reasoning models are, the class of problems they can solve, and then when you might use them and when you might not use them if other models are good enough. Thanks a lot.
Oh my God, I don't know if you saw all the chat. I think a lot of people are going to go check out your repo now. This is almost on dot. So I want to basically open it up to the community for questions. I know we have a couple of minutes, but I also want to point you to that QR code. We have a Discord channel. If there's a lot of interest, we'd love to have Jennifer come and answer questions there later as well. But for now, one of the things people were asking is, is it beyond research? Can reasoning models be used in practical applications? And I love the ones you kind of talked about, but are there any other use cases that you could share?
Yeah, so there's a question here around Power BI models in Fabric while maintaining explainability for non-technical use. Any best practices? Okay, so I was actually chatting with someone this morning who was doing advanced research on optimization problems. And that was a great example because optimization is one of those, and I was showing a constraint satisfaction problem essentially, but optimization is another one of those use cases where there's really higher level patterns in data, and a lot of times machines can find those patterns a little bit easier than we can, but we need to be able, you need the explainability and the transparency is so important. So questions like why would this, what would happen if we tried this supplier rather than this supplier, or what would happen if we prioritized this deliverable over that deliverable, like how would that affect the overall flow of things in a big optimization problem? And what these kind of models can do is really exactly that. It can give you the explainability of here's why it did that, and it kind of carries a lot more of that forward. So yeah, I do think reasoning models would be great for that category of problem as well. And then I didn't show a coding one. That's another one that I think people do a lot, like solving puzzles, like I showed Wordle and such, and just complex problems, optimization problems. A higher level code, like if you kind of do a high level, like give me a JavaScript, write a JavaScript program that, plays a simple game or something like that. It can do those kind of things decently well. Yeah.
I think the whole vibe coding thing is going on right now, where you just get immersed in this and it just helps you figure it out. So there's so much value here. Someone asked a very good question. They were like, reasoning models and context windows, right? How large are the context windows required for reasoning models? But I think that also goes back to what you were saying. Yeah, go ahead.
Yes, great question. So one thing, you can always find out the latest at aka.ms/OAI/models. That's like my cheat. The team does a great job doing that. But essentially, for 03 mini and 01, the input is 200K and the output is 100K. And for the 01 mini, it's input of 128K and output of, I think, 65-ish K, something like that. But the latest is always on, like, that's my go-to cheat sheet is go to that URL, aka.ms/OAI/models, and all the model information on all the models, what data centers they're in, what their training date cutoff was, like all of the good stuff that you need to know to work with them is all documented on that one page. It's fabulous. I'm there all the time.
I'm going to put that link into the chat right after. Nice. I think we're a little over time, but that's okay. We're going to take 2 more questions because they're good ones. One says, can you talk a little bit more about KV cache and how it plays into reasoning models? And then there was one which talked about Foundry, but I'll let you talk about the KV cache if you have any insight there.
Yeah. So when you're working with, so here I think is how I would think about it. When you're working with a reasoning model, it's using its own internal chain of thought to reason through things, and you can't like add new information halfway through that process. So the way I think about it is that they do have larger context windows. So what I would do is if you're, I tend to ask a higher level question with reasoning models, like instead of like a plan where you kind of would break things down a little bit step by step and kind of give it the lower level stuff with other models. This one, it actually seems to do better when you just give it like the high level thing and then dump any information it would need to solve that like in the initial context window. Now, there are experiments I've done with like multi-agent scenarios where we could do another whole talk on that one, honestly, Nitya. But the in that scenario, you can have like one grabbing some information and one of them kind of coming to some conclusions with the information it has at the time, and then the other one kind of feeding off of that and then making additional things. And so when you have little like different agents that are focused on different parts of a problem, then they can collaboratively come to a better solution. But I guess the short thing I would say is like grab the relevant information from the cache and get that into the context window at the beginning, because like it's not like you're adding stuff through unless it's a multi-agent kind of turn by turn chat there. Okay, and then what was the last question here?
The other question was, can you talk about how Azure Foundry handles reasoning tokens and how we can get a glimpse of them?
Yeah, so there on the output of the API, it does give you some information on here's how the how much of the or here's how many tokens were used each time around. So it will, if you do need to keep track of your tokens like input and output for like cost savings and that sort of thing, you can keep track of that. Just capture that in your telemetry on the output. There's a field there that will tell you how many tokens were used, and then you can just keep a running tally of that. And then that's
so very cool. This has been exciting. There's so many questions for you. So I'm going to take these and we'll write them up for you and put them after the fact. Just want to say thank you so much, Jennifer. This has been one of the most exciting ones. We're going to take you at your word. You're going to come back and talk agents with us another time. Thank you.
Right.
Okay.
Right. Thanks, guys.
Bye.